All right, today we're jumping into a real classic, a problem that's a staple of coding interviews, finding the longest palindromic substring. It's a fantastic problem because it really shows off your thinking process. We're going to go on a little journey, starting with a simple, intuitive idea and then leveling up to a solution that is just, well, it's brilliant. Let's get into it.
So before we even think about code, let's just think about patterns. Picture this. You've got a long chunk of text. Your mission, should you choose to accept it, is to find the longest piece of that text that is a perfect mirror image of itself. Something that reads the exact same forwards as it does backwards.
Now, the technical term for that mirror image is a palindrome. So what we're really trying to do is find the longest substring inside a given string that is a palindrome. For instance, if you have the string babad, you can spot bab and abba. Both are palindromes, they're both 3 letters long, so either one would be a totally valid answer. That's the core challenge we're tackling.
Okay, so how do we actually find it? Where do you even begin? Well, one of the most common and honestly most intuitive approaches is something called expand around center. And it's a great starting point because it uses the very definition of a palindrome to its advantage.
The idea behind it is actually super simple. Think about it. Every single palindrome, by its nature, has to have a center, a kind of mirror point. So what if we just go through every possible point in the string that could be a center and just expand outwards from there? If we do that, we are absolutely guaranteed to find every palindrome and, by extension, the longest one.
It's really just a simple 3-step dance. First, you pick a potential center point. Second, you start expanding outwards from that center, 1 step to the left, 1 step to the right, and you check if the characters match. As long as they do, you just keep on expanding. And third, you just keep a note of the longest one you've found so far. Then you just do it again for every single possible center. Simple as that.
But here's the catch. This is the little detail that trips a lot of people up. Palindromes can have 2 different kinds of centers. For an odd-length one, like ABA, the center is easy. It's the character B. But what about an even-length one, like ABA? Well, the center isn't a character at all. It's the invisible space between the 2 Bs. So any good solution has to account for both of these cases.
So this expand around center idea, it's pretty neat, it's easy to understand, and it definitely works. But, and there's always a but, isn't there? It has a performance flaw. And in a coding interview where efficiency can be everything, this flaw can be a pretty big deal.
Now, if you feed it a string like babad, this algorithm feels lightning fast. The expansions are all really short, and you find your answer almost instantly. This is what you'd call the best-case scenario, and it feels great.
But what happens when we throw it a curveball? What if we give it an input that's specifically designed to be tricky, like, say, a string where every single character is identical? This is where our simple, intuitive approach starts to, well, sweat a little bit.
See, with a string that's just a long line of A's, every single time we pick a center, what happens? The expansion will just keep going and going and going, all the way to the very ends of the string. And this doesn't just happen once, it happens for every single center we check. The algorithm is forced to do the maximum amount of work, over and over again.
And this leads us to the super important concept of time complexity, which we often talk about with big O notation. In this worst-case scenario, the complexity is O of n squared, or big O of n squared. What that really means is, as your string gets longer, the time it takes to run the algorithm can explode. If the string length n doubles, the runtime could quadruple. That can get really slow really fast. And for an interview, that might not be good enough.
So, this need for something faster, something better, brings us to Mannekers' algorithm. It was developed way back in 1975 by Glenn Manneker, and it is a truly brilliant piece of thinking that takes a clever shortcut to get to the answer in the best possible time. Which begs the question, can we really do better than ON squared? I mean, is it even possible to solve this in what's called linear time, ON? That would mean the runtime grows just in direct proportion to the string length, not exponentially. And the answer, amazingly, is yes.
The secret sauce to Mannekers' algorithm is that it uses the very symmetry we're searching for against the problem itself. It's all about reusing information we've already figured out so we don't have to do the same work twice.
Okay, so here is the big aha moment. As the algorithm scans through the string, it keeps track of the palindrome that stretches the furthest to the right. Now, for any new spot we check that's inside that big palindrome's boundary, we already know a ton of information.
we know it has a mirror image on the other side of the center. So we can just look at that mirror spot, see what palindrome length we already calculated there, and use that as a starting point. It's like saying, don't recheck something you've already seen in the mirror.
To make all of this work smoothly, Manikers uses this clever little hack. It transforms the string first. It sticks a special character, like a hash symbol, in between every single letter, and at the ends. So ABBA becomes this new string. And why do this? Because now every single palindrome, whether it was originally odd or even, is guaranteed to be odd length in this new string. It totally eliminates that annoying problem of handling two separate cases for centers.
So now we've got two main contenders. We have the simple, easy-to-code O of n square expand around center, and we have the super optimized but more complex O of n Monishers algorithm. So the big question is, which one should you actually use in a coding interview? Let's break it down. Expand around center is your reliable workhorse. Its biggest win is simplicity and the fact that it uses O of 1 space, meaning basically no extra memory. For many interviews, this is perfectly fine, and it's much easier to write correctly when you're under pressure. Monakers, on the other hand, guarantees that optimal O(n) time, but it's way more complex to implement, and it uses extra O of n space for that transform string. The right choice really depends on the situation.
All right, so if you're heading into an interview, here are the things you absolutely need to remember. First, always clarify the question. Are they asking for a substring or a subsequence? They are not the same thing. Second, if you're explaining expand around center, make sure you talk about handling both odd and even centers. Definitely be ready to explain that O of n squared worst case. And if you're going to mention Monachers, you have to nail its core idea, reusing mirrored results. And finally, don't forget the edge cases, like an empty string, a single character, or a string of all the same characters.
You see, by really digging in and understanding the deep structure of a problem, like the symmetry of a palindrome, we can make these incredible leaps from a good enough solution to a truly optimal one. And it just makes you wonder, right? What other hidden patterns are out there in all kinds of data, just hiding in plain sight, waiting for the right algorithm to come along?